Beneath quiet neighborhoods and ordinary city parks across America, there's a Cold War secret most people have no idea exists. Hidden underground were nuclear-armed Nike missile bases, ready to launch within minutes if war broke out. Some are abandoned, some are still sealed, and a few are hiding in plain sight. Today, we're uncovering the secret Nike missile bases hidden around U.S. cities. They were part of a massive defensive network that stretched across the United States. Rings of missile bases surrounded the country's largest cities: New York, Detroit, Los Angeles, Seattle, Chicago. The public rarely saw them clearly. Most sat hidden behind tree lines, inside forests, or on ordinary farmland. The Army called them Nike sites. Their purpose was brutally simple: shoot down Soviet bombers before those bombers could drop nuclear weapons on American cities. During the 1950s, the United States faced a new strategic reality. Long-range Soviet aircraft could cross the Arctic and reach North America. Early warning radar stations in Canada might give several hours of notice, but once those bombers appeared over American territory, the margin for defense became dangerously small. Fighter aircraft alone were not enough. The Army's answer was a weapon that could launch vertically from underground magazines, accelerate faster than any aircraft, and intercept bombers at altitudes above 60,000 feet. Construction crews built more than 200 of these installations across the country. Many were located only minutes from downtown city centers. Suburbs grew around them. Highways passed beside them. Children rode bicycles near their fences. Without realizing, nuclear-armed missiles sat beneath their feet. For almost 2 decades, these sites formed the last line of defense over the United States. Most Americans never knew how extensive the system was, and even fewer understand why it disappeared. Chapter 1: The Bomber Threat That Forced America Underground. In August 1949, an American reconnaissance aircraft flying over the Pacific collected unusual particles in its air filters. Laboratories soon identified the source: radioactive debris from a Soviet nuclear explosion. For 4 years, the United States had been the only nation possessing atomic weapons. That advantage disappeared almost instantly. American military planners immediately focused on a new question: how would those weapons reach the United States? The Soviet Union was rapidly expanding its fleet of long-range bombers. These aircraft were designed to carry heavy payloads across enormous distances. The most important of these bombers was the Tupolev Tu-95. 4 massive turboprop engines drove the aircraft across continents. Its range allowed it to depart Soviet bases, cross the Arctic, and approach North America from the north. Bombers following that route could reach American industrial cities within several hours: Chicago, Detroit, New York, Seattle. The United States already operated a defensive system built around interceptor aircraft. Radar stations would detect incoming bombers. Fighter jets would scramble to intercept them before they reached their targets. In theory, the system worked. In practice, it faced serious limitations. Radar coverage across the northern approaches to North America remained incomplete. Early warning lines in Canada could detect aircraft crossing the Arctic, but warning times were still short. Once bombers crossed into Canadian airspace, the clock began running. Interceptors had to launch, climb to altitude, locate the bomber formation, and engage before those aircraft reached American cities. Weather made the situation even worse. Storm systems frequently covered the Arctic route. Radar signals could weaken or disappear inside dense cloud layers. Tracking large formations became more difficult as aircraft moved south. Military analysts began running large-scale war simulations. The results caused serious concern. In many scenarios, bomber formations approached from multiple directions at once. Fighter interceptors struggled to respond quickly enough to every incoming group. Even when interceptors reached their targets, the outcome remained uncertain. A Soviet raid might involve dozens of bombers. Each aircraft could carry a nuclear weapon capable of destroying a city center. Stopping every aircraft was essential. One bomber slipping through would still mean catastrophe. By the early 1950s, American defense planners began searching for a different type of weapon. They needed something faster than a fighter aircraft, something that required no runway and no scramble time. a weapon already positioned near the flight paths of incoming bombers. The concept had begun several years earlier. Near the end of the Second World War, the United States Army started investigating guided anti-aircraft missiles. The research effort eventually brought together engineers from Bell Laboratories, Western Electric, and Douglas Aircraft. Their goal was ambitious: design a missile capable of intercepting high-altitude bombers using radar guidance from the ground. The system would track both the target aircraft and the missile in flight. Ground computers would calculate the intercept point. Radar commands would steer the missile toward its target. During the 1940s, this level of automation was extraordinary. Early computing systems relied on thousands of vacuum tubes. Radar consoles filled entire control rooms. Operators monitored glowing screens as antennas rotated above them. Despite the complexity, early test launches produced encouraging results. In one experiment, a prototype missile successfully intercepted a radio-controlled aircraft flying high above the New Mexico desert. The Army quickly recognized the potential. A missile could launch within seconds of detection. It could accelerate far faster than any bomber. It could climb to altitudes that pushed the limits of interceptor aircraft. The Army gave the system a new name: Nike. The name came from the Greek goddess of victory. By the early 1950s, the program moved from laboratory testing into full-scale development. The next step required something unprecedented. Missile bases would have to be built across the United States. Each major city would receive a defensive ring of launch sites. Radar stations would guide the missiles. Underground magazines would store them ready for immediate launch. If Soviet bombers crossed the radar lines in Canada, they would encounter multiple layers of defense. Interceptor aircraft would attempt the first engagement. Missiles would wait closer to the cities themselves. Construction began quietly. Army survey teams examined farmland outside Chicago, hills near Los Angeles, forests surrounding New York City. To most local residents, the projects looked ordinary. Some believed they were radar stations. Others assumed they were communications facilities. The truth sat beneath the soil. Concrete magazines, steel launch rails, radar towers rising above tree lines. Within a few years, more than 200 missile bases would surround American cities. One of the first would appear just outside Chicago, a quiet stretch of farmland that soon became the front line of the Cold War. A missile could launch within seconds of detection. It could accelerate far faster than any bomber. It could climb to altitudes that pushed the limits of interceptor aircraft. Chapter 2: Building a Missile Ring Around America's Cities. During the early 1950s, the United States Army faced a logistical challenge unlike anything it had attempted before. Designing the Nike missile had been difficult. Building the nationwide defense system required to use it would prove even harder. The Army intended to surround major American cities with rings of missile bases. Each installation needed radar tracking equipment, underground missile storage, launch systems, and trained crews. Every part of the system had to function together. The scale of construction was enormous. More than 200 Nike sites would eventually appear across the continental United States. These installations formed defensive belts around the most important population and industrial centers. Chicago received more than 20 missile sites. Los Angeles required an even larger network, stretching from the Pacific coastline into the surrounding mountains. New York City developed one of the densest defensive systems in the country, with bases positioned across northern New Jersey and the Hudson Valley. Selecting locations required careful planning. Missile bases had to sit close enough to cities to intercept incoming bombers before they reached their targets. At the same time, the installations required enough land for radar towers, launch areas, and security perimeters. Army planners often selected farmland, forest clearings, or undeveloped hills outside urban centers. Some sites appeared directly beside suburbs, highways, and agricultural land. Residents living nearby sometimes noticed construction crews digging large pits or installing tall radar towers. Few were told the true purpose of the projects. A standard Nike installation consisted of two separate sections, located several hundred meters apart. The first section was known as the Integrated Fire Control Area. This location contained the radar equipment responsible for detecting and tracking aircraft. Tall radar antennas rotated slowly above reinforced concrete buildings. Inside those buildings, operators monitored radar screens and calculated intercept trajectories. Several radar systems worked together. Acquisition radar searched large areas of sky for incoming aircraft. Once a bomber entered range, target tracking radar locked onto the aircraft and followed its movement. Another radar tracked the Nike missile itself after launch. Ground computers constantly compared the position of the missile and the bomber. Steering commands were transmitted by radio signals to guide the missile toward the predicted intercept point. For its time, the system was remarkably advanced. The second section of the base contained the launch area. This was where the missiles waited underground. Army engineers designed reinforced concrete magazines built below the surface. Each storage chamber held several missiles positioned horizontally inside protective racks. Hydraulic elevators raised the missiles to the surface when crews prepared for launch. Large steel doors opened at ground level. The elevator platform lifted the missile upward. Once above ground, the missile rotated upright and locked onto a launch rail. Fueling and final checks could be completed quickly. The system allowed several missiles to launch within minutes. Building these launch facilities required extensive excavation. Construction crews dug deep rectangular pits for the underground magazines. Thick reinforced concrete walls protected the chambers from blast damage. Electrical systems, radar cables, and communication lines connected the launch area with the radar control site. Every base required generators, control rooms, and secure communication links with regional air defense headquarters. Security around the installations remained strict. Tall fences surrounded both sections of the site. Guard posts controlled access roads. Military police patrolled the perimeter throughout the day and night. Despite the secrecy, the presence of Nike bases gradually became visible. Radar towers rose above trees and rooftops. Missile elevators occasionally lifted rockets into view during training exercises. Army vehicles moved regularly between radar sites and launch areas. By the mid-1950s, several American cities were surrounded by operational missile defenses. Chicago became one of the first regions to activate its system. Missile bases appeared at locations such as Arlington Heights, Des Plaines, and Waukegan. Each installation formed part of a coordinated defensive network, protecting the city from northern approach routes. Los Angeles required an even larger defensive ring. The region contained aircraft factories, naval facilities, and a rapidly growing population. Missile sites appeared along the coastline and across mountain passes surrounding the metropolitan area. New York presented a different challenge. Dense urban development left little open land within the city itself. Engineers placed many missile sites across northern New Jersey and along the northern approaches through Westchester County. From these positions, Nike missiles could intercept aircraft approaching from the Atlantic or from Canada. Across the country, construction continued through the decade. Surveyors, electricians, radar technicians, concrete crews all worked together to complete the expanding defense network. By 1954, the first Nike Ajax missiles entered operational service. Missiles now waited underground around many of the nation's largest cities. Radar operators scanned the sky. Launch crews rehearsed emergency procedures. The system remained on alert every hour of the day. For the first time, the United States had built a nationwide missile shield designed to defend its cities from nuclear-armed bombers. Yet, the system contained a growing weakness. Nike Ajax missiles carried conventional explosive warheads designed to destroy individual aircraft. Cold War planners increasingly worried about bomber formations arriving in large numbers. Stopping a single aircraft was one problem. Stopping an entire formation would require a different kind of missile. Chapter 3: The Missile That Carried a Nuclear Warhead. By the middle of the 1950s, the Nike Defense Network had begun protecting several American cities. Radar stations scanned the sky day and night. Missile crews drilled constantly. Launch teams practiced procedures that could place an interceptor in the air within minutes. The system worked, but defense analysts inside the Pentagon began to see a serious limitation. The Nike Ajax missile carried a conventional explosive warhead designed to destroy a single aircraft. That approach worked well against individual bombers. It became far less effective against large formations. Cold War intelligence suggested that Soviet attack plans might involve dozens of aircraft approaching together. Bomber groups could spread across several miles of sky while flying toward a target. Each aircraft might carry a nuclear weapon. Stopping such an attack would require multiple intercepts. Several missiles might be needed to destroy a single bomber. An entire formation could demand dozens of launches. Air defense planners began considering a different approach. Instead of destroying one aircraft at a time, they wanted a weapon capable of destroying several bombers with a single explosion. Engineers already working on the Nike system began designing a more powerful missile. The new interceptor became known as Nike Hercules. The Hercules missile was far larger than the earlier Ajax design. The rocket measured more than 40 feet in length and carried a significantly heavier payload. Its launch system also changed. 4 booster rockets fired during the initial launch phase, accelerating the missile rapidly into the sky. After several seconds, the boosters separated, allowing the main rocket engine to continue the climb. The larger missile could reach greater altitudes and engage targets at longer distances. But the most significant change involved the warhead. Engineers designed the Hercules missile to carry a nuclear device. To modern observers, the idea may seem shocking. Cold War planners viewed it as a logical solution. A nuclear explosion in the upper atmosphere would create a massive blast radius capable of destroying multiple aircraft at once. Any bomber flying within that radius could be destroyed instantly. Instead of attempting dozens of separate intercepts, a single missile might eliminate an entire formation. Several nuclear warheads were adapted for the Hercules system. Some produced explosive yields of several kilotons. Others were considerably more powerful. The missile shield protecting American cities would now include nuclear weapons. Military officials carefully evaluated the consequences. A nuclear explosion high above the ground could produce shock waves and radioactive debris. Under certain conditions, fallout might drift across surrounding regions. Yet planners believed the alternative would be far worse. A Soviet bomber successfully delivering a nuclear weapon directly over a city would cause vastly greater destruction. In that context, a defensive nuclear detonation appeared acceptable. Deployment of the Hercules missile began in the late 1950s. Many existing Nike Ajax bases were upgraded to support the new interceptor. Underground magazines were reinforced to accommodate the larger missiles. Radar equipment received improvements, allowing it to guide targets at greater distances. Missile crews received additional training covering nuclear handling procedures and launch protocols. Security around the warheads became extremely strict. Specialized Army units maintained custody of the nuclear devices. Storage areas were heavily guarded. Multiple authorization steps were required before a warhead could be armed. At some installations, the warheads remained separated from the missiles until an alert. At others, the weapons remained fully assembled and ready for immediate launch. To nearby civilians, the bases looked almost unchanged. The same radar towers rotated above tree lines. The same fences surrounded the launch areas. Training drills continued much as they had before. What many residents did not realize was that the missiles beneath those launch pads had become far more powerful. Several American cities were now protected by nuclear-armed interceptors. Chicago's defense ring eventually included Hercules-capable sites. The New York metropolitan region deployed similar weapons across northern New Jersey and along the Hudson Valley. Los Angeles, Detroit, and other industrial centers followed. The United States had created something unprecedented: nuclear weapons positioned around its own cities. If Soviet bombers appeared on radar screens, those weapons could detonate high above American territory. For several years, the system formed one of the most powerful air defense networks ever built. Yet even as the Hercules missile entered service, a new threat was beginning to emerge. Bombers would not remain the primary danger for long. A different kind of weapon was entering the Cold War. Ballistic missiles, capable of crossing oceans in minutes. Chapter 4. The day a Nike missile almost launched for real. For most of its existence, the Nike missile system operated quietly. Radar antennas rotated above forests, suburbs, and farmland. Soldiers monitored radar screens inside reinforced control rooms. Launch crews practiced the same procedures day after day. Yet the missiles never fired in combat, at least, not officially. During the most dangerous moments of the Cold War, however, the system came closer to launch than many Americans realized. One of those moments arrived in October 1962. The Cuban Missile Crisis pushed the United States and the Soviet Union to the edge of nuclear war. American reconnaissance aircraft had discovered Soviet ballistic missile installations under construction in Cuba. The discovery triggered an immediate military response. Strategic Air Command placed nuclear bombers on airborne alert. Naval forces moved toward the Caribbean to enforce a quarantine around the island. Across the United States, the Nike Defense Network also shifted to its highest readiness level. Missile crews, who normally conducted routine training, suddenly entered full combat alert. Control rooms that usually handled exercises now operated around the clock. The atmosphere inside those facilities changed quickly. Conversations became shorter. Movements became more deliberate. Every radar contact demanded careful attention. Operators watched their screens continuously. During normal operations, radar displays showed a mixture of civilian aircraft and scheduled military flights. During the crisis, every unidentified signal had to be treated as a possible threat. An aircraft approaching American airspace without proper identification could begin the first stage of a missile intercept. At several Nike installations, crews prepared missiles on launch rails outside of training exercises for the first time. The procedure followed a precise sequence. An elevator raised the missile from its underground magazine. Once above the surface, the rocket rotated upright and locked on to a steel launch rail. Radar teams verified that tracking equipment was functioning correctly. Launch crews checked electrical systems and guidance controls. If the order arrived, the missile could be fired within minutes. The tension continued for several days. Then one evening, radar operators at a northern air defense station detected an unusual signal. The contact appeared briefly on acquisition radar, before fading. Moments later, the signal returned. For a short time, the radar reflection resembled the signature of a high-altitude aircraft moving toward the United States. Air defense procedures required immediate investigation. Command centers contacted nearby radar stations to confirm the contact. Fighter interceptor units were alerted in case the signal represented an approaching bomber. Inside at least one Nike control site, the alert level increased again. Launch crews moved into position. Missile elevators began lifting rockets toward the surface. Tracking radar attempted to lock on to the unknown contact. The situation lasted only minutes. Additional radar stations soon reported that the signal behaved irregularly. The object did not follow the movement pattern of an aircraft. Weather specialists reviewing the radar data suggested another explanation. The signal likely resulted from unusual atmospheric conditions, temporarily reflecting radar waves. Within a short time, the contact disappeared completely. The launch preparations stopped. No missile fired. Incidents like this occurred several times during the Cold War. Radar reflections from storms, electronic interference, and high-altitude objects could produce signals that resembled aircraft. Air defense networks had to react immediately to every unexplained contact. The Nike system had been designed for that exact purpose. Missiles could move from underground storage to launch position in minutes. Radar guidance systems could direct them toward a target almost immediately after detection. During periods of political crisis, those capabilities placed enormous pressure on the soldiers operating the system. A mistaken radar signal could begin the first steps of a launch sequence. And once a nuclear-armed interceptor left its rail, the consequences would be impossible to reverse. Despite those risks, no Nike missile was ever fired in combat over the United States. The network remained active through the 1960s and into the early 1970s. But the strategic balance of the Cold War was changing rapidly. The Nike system had been designed to destroy bomber aircraft. A new type of weapon was beginning to dominate military planning: intercontinental ballistic missiles, capable of crossing oceans in less than 30 minutes. No surface-to-air missile could intercept them. Chapter 5: When missiles sat beside American neighborhoods. By the late 1950s, the Nike missile network had become a visible part of the American landscape. Radar towers rose above wooded hills and open farmland. Fenced military compounds appeared along highways at the edges of growing cities. Most civilians drove past these installations without giving them much thought. Few understood how close many of the bases stood to ordinary neighborhoods. In several parts of the United States, Nike missile sites were located only a short distance from homes, schools, and shopping centers. The placement was not accidental. Missiles designed to intercept bombers had to be positioned near the cities they were meant to protect. Air defense planners calculated that interceptors needed to launch quickly once enemy aircraft appeared on radar. If missile bases were placed too far away, incoming bombers might reach their targets before the intercept occurred. That requirement placed many Nike installations directly along the expanding edges of American suburbs. During the 1950s, metropolitan areas across the United States were growing rapidly. New housing developments spread outward from city centers into farmland and wooded hills. In some regions, the missile bases were built before the suburbs arrived. In others, the construction happened at nearly the same time. The result was the same. Residential neighborhoods and missile installations ended up side by side. The Chicago defense system provided several clear examples. Missile sites near Arlington Heights, Des Plaines, and other suburban communities became part of the defensive ring protecting the city. Radar antennas rotated above nearby trees, while families lived only a short drive away. Children riding bicycles along local roads sometimes passed the outer fences of the installations. From certain angles, they could see the tops of missile elevators during training drills. Most did not realize what those structures were. Southern California presented a similar situation. Los Angeles required one of the largest Nike defense networks in the country. The region contained major aircraft factories, naval bases, and a rapidly expanding population. Missile sites appeared along coastal hills, inside mountain passes, and across valleys surrounding the city. Some installations were located near newly built suburbs. Others stood inside state parks overlooking the Pacific Ocean. Drivers traveling through these areas often noticed tall radar towers rising above hillsides. The installations attracted curiosity, but the details remained unclear. Military authorities did not publicly advertise that some of the missiles carried nuclear warheads. Security rules limited what soldiers stationed at the bases could discuss with civilians. Many residents assumed the compounds were radar stations or communications facilities. Secrecy sometimes produced strange situations. In a few communities, hiking trails or picnic areas passed within sight of the missile bases. Families visiting nearby parks occasionally looked across valleys at radar towers turning slowly in the distance. Behind those fences, soldiers operated equipment designed to intercept nuclear-armed bombers. Daily life for the personnel stationed at Nike bases could feel surprisingly routine. Most installations resembled small technical facilities rather than large military bases. Radar control buildings looked similar to office structures. Launch areas were surrounded by grass fields, service roads, and equipment sheds. Personnel spent much of their time monitoring instruments, maintaining radar systems, and running practice alerts. Training drills occurred frequently. During some exercises, missile elevators raised rockets from underground magazines to the surface. The missiles rotated upright and locked onto launch rails while crews rehearsed launch procedures. Occasionally, these drills revealed the true nature of the installations. A missile rising above the ground could be visible from nearby roads or neighborhoods. For a brief moment, the quiet military compound displayed its real purpose. As the Cold War continued into the 1960s, journalists and local officials began asking more direct questions about the missile bases. Reports gradually confirmed what many residents had suspected. Several Nike installations surrounding American cities stored nuclear-capable missiles. The revelation surprised many communities. Bases that once appeared to be ordinary military facilities were now understood as part of the nuclear defense system protecting their cities. Public reactions varied. Some residents felt reassured knowing that defenses existed against possible bomber attacks. Others worried about the risks of storing nuclear weapons so close to homes and schools. Military officials emphasized the safety procedures surrounding the warheads. Security teams guarded the sites constantly. Launch procedures required multiple layers of authorization. Despite those assurances, the presence of the missile bases remained controversial in certain communities. Yet the Nike network continued operating for years exactly where it had been built. Radar antennas rotated above suburban skylines. Missiles waited beneath the ground. And thousands of American families lived their daily lives, only a short distance away. Chapter 6: The Hidden Technology That Guided the Missiles. The missiles stored beneath Nike launch sites were only one part of the system. The real complexity existed inside the radar control stations. These facilities contained the technology that allowed the interceptors to find their targets. Without that equipment, the rockets would have been little more than unguided projectiles. The Nike Defense Network relied on a method known as command guidance. Instead of carrying its own radar, the missile depended on instruments located on the ground. Radar stations tracked both the incoming aircraft and the missile after launch. Electronic computers then calculated where the two would meet. Radio commands transmitted from the control site adjusted the missile's flight path during its climb. For the 1950s, this approach required remarkably advanced technology. A typical Nike integrated fire control installation used several radar systems working together. The first radar searched the sky for incoming aircraft. This system, known as acquisition radar, scanned large sections of airspace and displayed potential targets on the operator's screen. When a contact appeared, another radar system took over. Target tracking radar locked onto the aircraft and followed its movement continuously. The system measured the bomber's position, altitude, and direction of travel. At the same time, a separate radar monitored the Nike missile itself after launch. Once the rocket left the rail, this tracking radar followed the missile throughout its flight. The control system now had two moving points: the aircraft and the missile. Inside the control building, electronic computers compared the position of both objects. These machines calculated where their paths would intersect if each continued moving at its current speed. That predicted location became the intercept point. Guidance commands were then transmitted to the missile through radio signals. Small control fins adjusted the missile's direction while it climbed toward the target. The process repeated constantly. If the aircraft changed direction, the radar systems detected the movement. The computers recalculated the intercept point and transmitted new commands to the missile. All of this occurred within minutes. During a typical engagement, the guidance system performed thousands of calculations. Most of the equipment relied on analog computing technology rather than digital processors. Electrical signals represented speed, distance, and direction. Complex circuits converted radar measurements into steering instructions for the missile. Large racks of electronics filled the control rooms. Vacuum tubes amplified the radar signals. Cooling fans ran continuously to prevent the equipment from overheating. Technicians carefully monitored every component. Even a small malfunction could disrupt the guidance process. Operating the system required extensive training. Personnel learned to interpret radar signals, operate the computing equipment, and coordinate with launch crews during an intercept. Training exercises simulated bomber formations approaching defended cities. Radar operators practiced tracking the aircraft while launch crews guided missiles toward imaginary targets. Detection, calculation, and interception had to occur almost instantly. The technology worked remarkably well for its time. During numerous test launches, Nike missiles successfully intercepted target drones flying miles above the desert testing ranges. Engineers continued improving the radar and computing systems as the defense network expanded. In many ways, the Nike program pushed the limits of electronic engineering in the 1950s. The radar stations and analog computers represented some of the most advanced military technology of the period. Yet all of this equipment served a single purpose: guide a missile toward an aircraft moving high above the Earth at hundreds of miles per hour. For several years, the system performed that mission effectively. But the technology had been designed for one specific threat: Aircraft, flying through the atmosphere. A new class of weapons was beginning to appear, one that moved far faster and far higher than any bomber: ballistic missiles. Once those weapons entered the Cold War, the Nike system would face a challenge it had never been designed to solve. Chapter 7: The weapon that made Nike obsolete. For nearly a decade, the Nike missile network formed the backbone of American air defense. Missile sites surrounded major cities. Radar stations scanned the skies continuously. Launch crews remained ready to fire interceptors at approaching aircraft. The entire system had been built for one purpose: stop nuclear-armed bomber aircraft before they reached American cities. During the 1950s, that threat appeared very real. Soviet long-range bombers could potentially cross the Arctic and approach North America from the north. Air defense planners expected large formations of these aircraft in the opening hours of a nuclear war. The Nike system was designed to destroy them. But by the end of the decade, a new weapon began changing the entire balance of nuclear strategy: the Intercontinental Ballistic Missile. Unlike a bomber aircraft, this weapon did not fly across continents through the atmosphere. After launch, the rocket climbed into space before following a long arc toward its target. The warhead then re-entered the atmosphere at extraordinary speed. From launch to impact, the journey might take less than 30 minutes. This new technology changed the basic timeline of air defense. Bomber aircraft required hours to reach their targets. Radar networks could detect them far from American territory. Interceptors and missile batteries had time to respond. Intercontinental missiles removed that advantage. Once launched, the weapon traveled thousands of miles at speeds far beyond any aircraft. By the time radar detected the incoming warhead, it might already be descending toward the target. No interceptor missile of the 1950s could reach it. The Soviet Union successfully tested its first operational intercontinental ballistic missile in 1957. That same year, another event demonstrated the power of long-range rockets: the launch of Sputnik. The small satellite orbiting the Earth shocked much of the world. To military planners, the message was clear. If a rocket could place an object into orbit, the same technology could deliver nuclear weapons across continents. American defense officials quickly understood the implications. The Nike system had been designed to intercept aircraft flying within the atmosphere. Ballistic missiles traveled far above those altitudes, before plunging downward at enormous speed. The interceptor network protecting American cities could do almost nothing against such weapons. Despite this growing limitation, the Nike bases did not disappear immediately. Bomber aircraft still existed, and military planners believed they might still be used during a nuclear conflict. The missile sites therefore continued operating through the 1960s. Radar stations remained active. Missiles waited inside underground magazines. Soldiers trained constantly for a type of attack that was becoming less likely with each passing year. At the same time, the United States began developing new defensive systems. Some projects focused on detecting missile launches as early as possible. Massive radar stations appeared across the northern regions of North America, watching the skies for objects rising above the horizon. Other programs attempted something even more ambitious: intercepting ballistic missiles in flight. These efforts would eventually produce entirely new defense systems designed for space-age warfare. The strategic focus of the Cold War was shifting. Instead of defending cities from bombers, military planners now prepared for nuclear missiles traveling across oceans in minutes. In that new reality, the Nike system slowly lost its central role. The network had once represented the most advanced air defense technology in the world. Now it faced a threat it had never been designed to defeat: weapons that traveled beyond the atmosphere. Chapter 8: The Slow Shutdown of America's Missile Shield. By the late 1960s, the purpose of the Nike missile network was beginning to fade. For more than a decade, the system had served as the primary defense against nuclear bomber attacks. Hundreds of interceptor missiles waited beneath launch sites surrounding the nation's largest cities. Radar stations operated continuously. Missile crews remained ready. But the strategic focus of the Cold War had begun to change. Intercontinental ballistic missiles had become the dominant nuclear threat. A weapon traveling through space at enormous speed could reach its target long before interceptor systems designed for aircraft could respond. The Nike bases had never been designed for that kind of war. Maintaining the nationwide network also required significant resources. Each installation needed trained crews, radar technicians, security personnel, and constant maintenance of complex electronics. Hundreds of missiles remained stored inside underground magazines across the country. By the end of the 1960s, defense planners began reconsidering the value of the system. Some locations still held strategic importance. Others no longer justified the cost of operation. The first closures began quietly. Certain Nike Ajax sites had already been retired when the larger Hercules missile replaced them at selected locations. In other regions, entire installations were shut down as air defense priorities shifted. Budget pressures accelerated the process. Operating hundreds of missile bases required thousands of personnel and continuous upgrades to aging radar and computing equipment. At the same time, new defense programs demanded funding. Early warning radar networks, missile detection systems, research into intercepting ballistic warheads. Gradually, the nationwide Nike network began shrinking. Some bases closed during the late 1960s. Others continued operating into the early 1970s before being deactivated. In many communities, the radar towers and fences simply disappeared. Missile elevators were sealed. Radar antennas were removed. Launch rails were dismantled. In some locations, the Army filled underground chambers with soil or sealed them beneath concrete slabs. The shutdown process often occurred with little public attention. For years, the installations had blended into the background landscape surrounding American cities. When the military departed, many residents barely noticed the change. Yet these quiet closures marked the end of one of the largest defensive construction programs in American history. More than 200 missile sites had once formed a protective ring around the United States. Within a few years, most of them were gone. Some locations were abandoned entirely. Others were transferred to local governments or sold to private owners. Beneath the ground at many of those sites, reinforced concrete chambers still remained. Silent structures, built for missiles that would never launch. The Cold War had entered a different phase. The next generation of defense systems would no longer watch for bombers approaching the horizon. They would search the skies, far beyond the atmosphere. Chapter 9. What happened to the missile bases? When the Nike Defense Network began shutting down in the late 1960s, the United States Army faced a practical problem. Hundreds of military installations were suddenly no longer required. Each location contained concrete launch bunkers, radar towers, control buildings, and security infrastructure. Many stood on land that had become increasingly valuable as nearby suburbs expanded. The Army now had to decide what would happen to these sites. Some installations were dismantled completely. Radar towers were removed, launch rails were cut apart. Sensitive electronics were taken away by military technicians. Once the equipment disappeared, only the physical structures remained. Underground magazines built from reinforced concrete proved far more difficult to remove. Demolishing them would have required major excavation. In many places, the Army chose a simpler solution. The chambers were sealed and covered with soil or gravel. After that, the land could be transferred or sold. Across the country, former missile installations gradually entered civilian life. Some became public parks. The wide-open land surrounding radar and launch areas made these locations suitable for recreation. Roads once used by military vehicles often became park access routes or walking paths. Visitors moving through these parks rarely realized that missile launch systems had once operated beneath the ground. Other sites found practical civilian uses. Radar control buildings were sometimes converted into storage facilities or maintenance offices. Launch areas became municipal service yards or equipment depots. Private companies purchased several former installations. The heavy concrete bunkers originally designed to protect missiles offered secure storage space. Their thick walls and stable interior temperatures proved useful for industrial purposes. Urban development transformed many other locations. Suburbs that had once surrounded the installations continued expanding. Housing developments eventually spread across land that had once belonged to the Army. Streets and houses appeared where radar antennas had once rotated. In some places, the only reminder of the past was an unusual concrete structure hidden among modern buildings. Not every location disappeared quietly. During the 1980s, historians and preservation groups began recognizing the importance of Cold War defense sites. A small number of former Nike installations were preserved. One of the best-known examples stands in the Marin Headlands, north of San Francisco. The launch site there became part of a national park. Today, the installation operates as a museum, showing how the Nike system once functioned. Visitors can watch demonstrations in which a Nike missile is raised from its underground magazine using the original elevator mechanism. The equipment no longer carries warheads, but the machinery still moves exactly as it did during the Cold War. Standing beside the launch rail, visitors can see how the system once prepared for launch. Radar towers overlook the Pacific coastline. Underground chambers remain beneath the hillside. For a moment, the quiet landscape reveals what the Nike Defense Network once represented. Across the rest of the country, many former locations remain hidden in plain sight. Some are covered by forests. Others lie beneath warehouses, schools, or residential neighborhoods. Concrete bunkers still exist below the surface at numerous sites. Most people living nearby never notice them. Yet these silent structures mark the places where missiles once waited beneath American soil. For nearly 2 decades, they formed part of a nationwide shield built to defend the country from nuclear attack. The radar towers have vanished. The missiles are gone. But the ground where they stood still holds the history of the Cold War. Chapter 10: The Legacy of the Nike Missile Network. When the final Nike missile bases closed during the early 1970s, a remarkable chapter of American engineering quietly ended. For nearly 2 decades, interceptor missiles had waited beneath launch sites surrounding the nation's largest cities. Radar stations scanned the sky for approaching aircraft. The entire network had been built for a specific moment in history, a period when nuclear war appeared possible, at any hour. Although the missiles were never fired in combat, the influence of the program extended far beyond the years in which it operated. The project transformed the way military planners approached air defense. Before the 1950s, protecting cities from air attack depended largely on fighter aircraft and anti-aircraft guns. Pilots had to intercept bombers directly, while artillery crews attempted to destroy aircraft with ground fire. The Nike program introduced a different concept. Missiles launched from the ground could destroy aircraft without requiring a pilot in the air. Radar guidance allowed interceptors to track targets at high altitude and approach them at extreme speed. Defensive weapons could remain permanently positioned near major cities. This principle would later become standard in modern air defense systems. Many countries eventually developed missile networks based on similar ideas. Radar detection, ground-controlled guidance, interceptors launched from fixed defensive sites. The technology created for Nike also influenced other military developments. Engineers working on the system refined radar tracking techniques and electronic guidance equipment that would later appear in additional missile programs. Control stations used some of the most advanced electronic computing systems of the 1950s. These early machines performed rapid calculations that allowed missiles to intercept aircraft moving hundreds of miles per hour. The work helped accelerate the development of military electronics during the Cold War. The program also left physical traces across the American landscape. Even after most installations disappeared, the locations remained scattered across the country. Concrete launch bunkers, buried magazines, and abandoned service roads still exist at many former sites. Some lie hidden beneath forests. Others sit below suburban neighborhoods where families live only a short distance above structures built for nuclear defense. These places represent a unique moment in American infrastructure. Few Cold War projects created such an extensive network across the country. Radar sites, control stations, and launch facilities once operated together as a coordinated defensive shield. Thousands of soldiers and technicians maintained the equipment year after year. They trained constantly, for a mission that fortunately never occurred. The program also demonstrated how rapidly military technology could change. When the first missiles entered service during the 1950s, they represented some of the most advanced defensive weapons ever constructed. Within little more than a decade, new technologies were already replacing them. Ballistic missiles transformed the strategic balance of the Cold War. Weapons traveling through space could reach their targets far faster than aircraft. Air defense systems designed to stop bombers suddenly faced threats moving beyond the atmosphere. The Nike network could not adapt to that transformation, yet the achievement remains impressive. A nationwide missile defense system, built during one of the most tense periods of modern history. Today, the radar towers have mostly disappeared. The launch rails are gone. But beneath parks, forests, and neighborhoods across the United States remain the foundations of a forgotten missile shield. The forgotten shield above America. For nearly 20 years, a hidden defensive system surrounded many American cities. Missiles stood ready beneath quiet fields and wooded hills. Radar antennas turned slowly above control stations while soldiers monitored their screens day and night. Most Americans rarely noticed the installations. Yet during the most dangerous years of the Cold War, these sites formed the final barrier between nuclear bombers and the cities below. The Nike network represented an extraordinary engineering effort. Hundreds of launch sites, radar stations, and control facilities operated together across the United States. Underground magazines stored interceptor missiles, while electronic guidance systems waited for the moment they might be needed. Thousands of soldiers trained to operate that system. Their task was direct and unforgiving. Detect enemy aircraft, launch interceptors, destroy nuclear bombers before they reached American cities. Fortunately, that moment never arrived. The missiles remained in their launch chambers, but the existence of the system reveals how seriously both sides prepared for nuclear war. Across the United States, traces of that preparation still remain. Concrete bunkers lie hidden beneath parks and forests. Abandoned service roads lead to hills where radar antennas once watched the horizon. Many people pass these places without realizing what once stood there. Yet these silent locations mark a remarkable period in technological history. The Nike program showed how rapidly engineering could respond to new threats. Within a few years, the United States created one of the most complex air defense systems ever constructed. And just as quickly, that system became outdated. Ballistic missiles transformed nuclear strategy. Weapons traveling through space could reach their targets far faster than aircraft approaching through the atmosphere. The missile shield built to defend American skies could not adapt to that change. Still, the legacy remains. Modern air defense systems continue using principles first demonstrated by Nike. Radar detection, guided interceptors, coordinated defensive networks. The missile bases that once protected American cities have largely disappeared. But beneath parks, forests, and neighborhoods across the country remain the foundations of a forgotten defense system. A silent reminder of a time when the skies above America were guarded by missiles waiting beneath the ground.